let's continue our next section. Rational function. When you say rational function, you have polynomial over polynomial. So you have polynomial on the numerator and polynomial on the denominator. So we want to find a vertical and horizontal asymptote here. For the vertical asymptote, first you need to write the function in the lowest term. If you can reduce it, and then set the denominator equal to 0 and then solve for x. For example, I have this function f of x is equal to x squared minus 9 over x to the cube minus 4x. So I'm going to write in the lowest term. So I'm going to factor it first. So I'm going to have x plus 3, x minus 3 on the numerator. On the denominator, I factor out the x. So I'm going to have x squared minus 4. Right? Next, I'm going to factor the denominator again. I'm going to have x plus 3, x minus 3, and x plus 2, x minus 2. I can't reduce them, so that's all I can do. If I can reduce them, I would, but I can't. So if I set denominator equal to 0, so x can be 0 plus or minus 2. So my vertical asymptote is going to be x equal to 0, x equal plus or minus 2. Alright, now let's look at the horizontal asymptote. The horizontal asymptote, you have these three properties here. You look at the degree of numerator and denominator. If the degree of numerator less than the degree of denominator, then your horizontal asymptote will be y equal to 0. If degree of numerator equal the degree of denominator, then your horizontal asymptote will be the ratio of the coefficient of the numerator and denominator. Now, if the degree of numerator is greater than the degree of denominator, then you don't have horizontal asymptote. So let's look at our example. The first one, the degree of numerator is 1. The degree of denominator is also 1. So it's fall in the second property here. So the horizontal asymptote is going to be y equal the ratio of coefficient of numerator and denominator. So the leading coefficient of numerator is 5. Leading coefficient of denominator is negative 3. So it's negative 5 over 3. That is the horizontal asymptote. The negative can go up, can go down, or can go in the front. Now let's look at the second example. The numerator is degree 1, denominator is degree 2. So the degree of numerator is less than the degree of denominator. So the horizontal asymptote would be y equal to 0. Right? The next one, I have the degree of numerator is 2, degree of denominator is 1, so degree of numerator is greater than degree of denominator. So the horizontal asymptote will be 9. Alright, let's see more example. Let's go to our last section of chapter 3, variation. So variation here, you're going to have relationship with 2 or more variable. Let's look at the first one. Direct variation is mean direct, so you're going to have y equal to kx. K is constant here, and you have 2 variables, y and x. Alright. Now if direct variation with power, one of them will have power. So as you can see here, x has some power and k is constant. So y equal to k x to the n. However, if you have various inversary is mean that the other one would be reciprocal on the denominator. So you have y equal to k over x, where k is a constant. If they say inverse variation with power, so one of them will be in the exponential form. Now look at number 5. Z varies jointly with the nth power of x. So and m power of y. So you're just going to have c equal to k. K is a constant here. X is to the n and y is to the m. Now if c is vary directly with the n power of x, so you're going to have c equal to k, x to the n. K is the constant. However, inversely with m power of y. So y is on the denominator here, y to the m. Now let's look at example. I have y vary inversely as c. So this is going to be under number 3, various inversely. So I'm going to have y. Alright, so it's going to be y vary inversely as c. So I'm going to have k over c. Alright? Y varies inversely as c. K here is constant. It's like this one. But instead of yx, I have yc. Right? So when y is 24, we don't know what k is. My c is 1 over 6. Alright? So to solve this, I can multiply 1/6 to both sides. So I have 1 over 6 times 24. If I multiply 1 over 6 to the right hand side, I will have k by itself, which means k is equal to 4. Again, k is a constant. Alright? Now I'm going to write it y equal kz. This is our equation. Now, they want you to find y when z is 1. So y, k is constant, which is 4, c is 1. So y would equal to 4. Alright? Now let's look at application. Hooke's law states that the force required to stretch a spring by x unit is direct proportional to x. So this is direct relation. So I'm going to use the first one, direct variation, right? So the force, so I use the notation F, alright? The force required to stretch a spring by x unit is directly proportional to x. So I'm going to have F equal to kx. K is a constant. I'm using the first property here. Right? So it said that the equation states that the force of 10 pounds. So the force now is 10 pounds. We don't know what K is. We don't know what K is. Stretch a spring by 4 inches. So 4. Right? From here I can solve for K. So K will be 10 over 4. Alright. Next it said that find the force. So we need to find the force. Let me write the formula again. F is equal to kx. We want to find the force required to stretch a string by 6 inches. So we need to find the F. But we know the constant is 10 over 4. Alright, constant is 10 over 4, and we need to stretch a spring by 6 inches. So I'm going to have to put times 6 here. So it's 60 over 4 is 15. The unit here is pound. Alright, 15 pound. Alright, so we finished chapter 3.